Welcome. In this video, we'll be taking a look at how to solve a linear equation in two variables. So what I've done is I've actually written up just an equation in one variable because I want you to see how they're similar to one another. So the equation that I wrote up is x plus 3 equals 4. And then what we did was we subtracted 3 from both sides, and we got an answer of x equals 1. Now, one way I could check to see if that answer actually works is to plug 1 in for x. And 1 plus 3 is equal to 4, so this is going to be a valid solution. So for the equations that we've solved so far, there's only been one solution. In other words, there's only been one number for x that actually works. When we're working with two variables and we have one equation, there are going to be many times where there are many more than just one solution. So what I'm going to do is just pick two random numbers and let's see if we can figure out whether or not they are solutions, and then I'll show you the steps for how to solve this problem specifically. So we're going to just try sort of like a trial and error kind of thing. And so since A and B are what we're trying to solve for here, let's just pick two numbers. Suppose A is 3 and B is 1. Let's see if we can check to see if this is a solution or not. So if I plug 3 in for A, 5 times 3 is 15, minus the 1, well, 15 minus 1 is certainly not equal to 1, so that tells me this is not a solution. So the way that we would write this up is we would say 3 comma 1 is not a solution. So notice how I've abbreviated this A equals 3 and B equals 1. What I've done is I've written it as an ordered pair. And so again, with an ordered pair, the first number is going to correspond with the letter that would appear first in the alphabet. So what I would know is that since my equation contains A and B, the first number is my A number, the second number is my B number. Okay, well, just reasoning back a little bit, if I plug my 3 in for A, that would have given me 15. Can you think of a number that I could subtract from 15 that would give me 1 as an answer? Well, let's see if we can figure this out systematically. So step 1 for solving these is to not plug numbers in for both variables, but plug a number in for one variable to start out with. So we're going to plug a number in for one variable. So what I'm going to choose to use is our A equals 3. I could have chosen anything, but I'm just choosing 3. So if I do that, what I end up with is, well, I started with 5A minus B equals 1. And if I plug my 3 in for A, I get 5 times 3 minus B equals 1. Well, 5 times 3 is 15 minus B equals 1. So now look what we have. We've got an equation with only one variable in it now. So step 2 is to solve what's left. So what I'm going to do is solve this equation for B. So I've got 15 minus B equals 1. I'm going to subtract 15 from both sides. The 15 and negative 15 make 0, so I'm left with negative B equals 1 minus 15 is negative 14. Divide both sides by negative 1, and I'm left with B equals 14. What that tells me is that when A equals 3, as long as B equals 14, I've got myself a solution. Let's check to see if that actually works. So 5 times 3 is 15, minus 14 is 1. So that is a solution. Now, is that the only solution? Well, it's the only solution if A is 3, but we didn't need to pick 3 for A. We could have picked 2 or 1 or 0 or 100 billion, we could have put any number in for A, and once I put that number in for A, it's going to have a partner that together are going to make a solution. So just to show you that it's not fixed to just this one solution, our answer would just be 314 in this case. But I just want to show you one more example. So suppose we would have chosen, for example, A equals 1 instead. Well, if A equals 1, then I'm going to go through the same routine. I plug 1 in for A. 5 times 1 is 5. And now I'm going to solve this equation for B, so I'm going to subtract 5 from both sides. And what I end up with is negative B equals negative 4. Divide both sides by negative 1. And I end up with B equals 4. So what that tells me is if A is 1 and B is 4, then I have a second solution. So a second solution would be 1, 4. And just to verify that that works, 5 times 1 is 5, minus 4 is 1. So what we found so far are 2 solutions. But do you think there are only 2 solutions? Well, no. Again, I could have picked anything that I wanted for A. Okay, I want you to try number 2, pause the video, and then restart it after you've given it a try. Okay, so for number 2, we could have, again, chosen any number to plug in for M or any number to plug in for N. So since M comes first, I'm just going to plug a number in for M. So let's say M equals 2. Well, if M equals 2, let's plug that in and see what we get. 4 times 2 plus N equals 4. 4 times 2 is 8, plus N equals 4. Minus 8 from both sides. And we get N equals negative 4. So my solution would be, since M comes first in the alphabet, the M number comes first, then the N number. So a possible solution would be 2, negative 4. Now, of course, you didn't have to choose M equals 2. But what you would want to do is plug your numbers in to the original equation and make sure it works out. In my case, 4 times 2 is 8, plus negative 4 is 4, so mine checks out. Does yours?